All right, everybody. Meteorologist Jamey Singleton with you here, and not wanting to get too many people excited just yet, but I've been watching a rotating thunderstorm coming out of Franklin County. Franklin County's in the clear for now, although I know it's hard to see. There's another storm within all this ground clutter that's coming out of Hardy. That one I'm not watching, but there's a little bit of a hook that keeps trying to get going around southern Franklin County. And again, I apologize. This map's almost impossible to see. I'm going to try to switch you over here in just a second, but I do have the ability to overlay some roads and stuff. So while I'm there, let me go ahead and put in some cities for you, give you an idea of where we're talking about. Right near Philpott Lake in Bassett, and there is a little bit of a hook there just to the east of Stone Store. There is no warning out with this. National Weather Service does not have a warning out, and one of the reasons could be because we just don't have the actual wind speeds to verify that, but we do actually have the rotation, and we've got a front. If you were paying careful attention to my Patreon earlier, we talked about a front that's laying right through the area, and this is a dual view, but you can see that's the stationary front between the mountains and the Piedmont, where winds are coming out of the east to the Lynchburg area. In Danville, your winds are out of the east. In Spencer and Martinsville, your winds are out of the west. And it's right along that front. You have to watch any little shower or storm that gets going. So if we look here, you can still see a bit of a hook echo just to the south of West Bassett. And to repeat, there is no warning with this. I'm alerting you just because I think a warning could be issued if this doesn't intensify a little bit more. In other words, it wouldn't take a lot more, in my opinion, to cause the Weather Service to issue a warning. So right now they've got a special weather statement in effect. Let's see if I can pull that up here. Winds in excess of 30 miles an hour. They had Ferrum, Stanleytown, Oak Level, Figsboro. This is mainly a Henry County Bassett storm at the moment. Make sure I've got the live feed up in case they do put something out here. But heading toward Dillon's Fork and Pleasant Grove, and on this right view, you can see the greens and the reds within radial distance of the Floyd County radar. So you've got some reds going toward the radar and greens going away from the radar, and we'll animate the last 7 frames, and you can see that this has actually been rotating for quite some time. You could follow it back there. In fact, if you go a little bit further back, Jamey, we're going to do 21 frames as I talk to myself on the Sunday night. It'll take a second to load. But right around Henry's, right where the front was, and we had a pretty good-sized shower move just south of Wirtz and just west of Rocky Mount earlier. And then that, once it got out toward Southern Crossroads near 40, near the college there, it really started to take on more of a supercell shape, and a very small one at that. But you can also see there near the Philpott Lake area, one area of a little hook there embedded within this. And this is very, very small, not pronounced at the moment. But I tell you, it's there. It's on our mapping software. You can see the hook, and you can also see clearly some rotation. It may look a little bit weak to you, but that's the actual rotation. What we can do is show you that horse pasture in Spencer in 58. You may want to watch this. And again, this is coming out of the north. Not a lot of lightning with it, not a lot of noise with it to give you any concern, but I can look at the actual amount of rotation on one of my weather computers, and you can see it's highlighted that Ferrum to horse pasture vicinity over the past hour. And I'll put this in motion, and we'll zoom in a little bit more. The county lines are a little hard to see here. But as that loads, you'll be able to follow that track. So this is not like something that suddenly spun up. This shower's had some rotation in it for quite some time, and it's unique to call it a shower and not technically a thunderstorm because I don't have any lightning outside. But that rotation does not weaken, it doesn't strengthen, it kind of stays on the low to moderate range, which warrants that special weather statement. But it also has folks, I'm sure, like me thinking, that are in the weather field, if this thing gets a little bit stronger here, we may have a warning on our hands. And it could just be where it just crossed the front. That could just be the front coming into play there. Either way, I need to tell you about it, because what I don't want to be doing is following the weather. I want to be ahead of the weather for you. So we're going to go back now and keep that in motion now, and we'll pop up the WSV3 radar, and you can see there's not really much pronouncement on this particular scan that you can see. In terms of a hook, it depends on what enhancement you use, but you can see everything. Your Bassett Stanley Town, now south of town. And I've got the dew points popped up here near Blue Ridge Airport and Horse Pasture. Dew point of 68, temperature 72, because there is a dew point gradient that's occurring. You can see out toward Galax, the drier, more pleasant air we've been forecasting has indeed made it to the mountains on westerly winds. And if you pull up some of these winds right here, you'll be able to see as it loads, you'll be able to see winds coming out of the west in the mountains, and then winds coming more out of the east into the Lynchburg area. And whether it loads or not, just trust me on that and go to Patreon and you'll find out. I'm popping up the METARs now, and I've got them as densely spaced as I can. But there are two storms, and I'll watch this one too around the lake because the atmosphere is very similar here. So what I was looking for on our station reports to see if we see, yeah, we can see a 64 to 65 dew point, and a bit of a gradient between the upper 60s and lower 60s and even some 50s. So that may be playing a role here too. But you can almost draw kind of a miniature cold front with these systems as they spin. As they spin, they kind of resemble, and actually they operate as miniature storm systems. So let me show you what I'm talking about here. And I'm going to go to the other radar to kind of give you an idea. Hopefully by then we don't have a warning, but we still have rotation. You can see it right there just to the southwest of Stanleytown. It's missing Martinsville. That's how small this little cell is, and that's why it may not be much for concern. But if we look at the correlation coefficient and start to see an area in here that looks more yellow and well-defined, we know we've got trouble. We put it in motion and we can't see that, but you could even see two hooks on that correlation coefficient there. One going there and one going there, and that's why I look at the actual square pixels. They're the actual radar data that's coming in. It's not a remap software like your weather app or whatever it uses. That can be useful sometimes, but not in conditions like this. So it's still developing a little bit of a couplet there, and if you look back at the base velocity, you get a little bit of a visual here. Let me analyze this a little bit for you so you'll see what I'm talking about. Try to get a cold front that would pop out for you here. All right, so we've got our storm that's popping up, and on the back side of the storm, we've got wind shear causing everything to spin counterclockwise. So the storm towers into the sky, and it taps this colder air, rain-cooled air. That tends to come down when a storm is circulating. It comes down on the southwest flank of the storm. So there's almost like a miniature cold front in here. In fact, it may be closer to here. But think of that as the cold front. Notice it's not raining back in here. And then out ahead of the actual storm to the north and east, just like you'd have in low pressure, you've got a bit of a warm front. And this is where just to the north it's raining heavier and heavier, and then all of a sudden you get into the warm sector and everything's a little more quiet, theoretically speaking. But right along this warm front you have winds that are spinning on a horizontal axis. In other words, like a pencil in your hand. What happens is these two fronts will occlude and will tighten the spin up just enough. And that's what, we have it in big time meteorology. We call it an occluded front. But it'll wrap itself in with the wind shear, and if it tightens enough, and you can introduce anything into the spin. So you've got generalized spin, and you can see it with the radar is what I'm saying. And that's why when you have a warm front in the wintertime, it rains really hard. That's called overrunning, or we get a lot of heavy snow. It's the same thing, just on a much smaller scale. You see on to the right here, the velocity data still showing very tight but very weak rotation. So I'm not surprised that there's not a tornado warning, but I wouldn't be surprised if there were. And I'd hate to be turning my computer off and calling it a night when I've got a storm that's starting to kick up on radar here. We're going to look at different levels here as we can on our radar picture here. We'll load up the first panel here. And what we're looking at is the current image. trying to see if I see anything more pronounced. We're going to go back up into the sky now, and you see a little more of a pronouncement of a hook here as we start to lose some of the ground clutter. We're at about 1.4 degrees, so we're looking up at about 3,300 feet. And this is smooth data. Here's the actual data, but you can see it either way. You can see a little bit of a hook there. And now we're going up further into the sky where it becomes more diffuse, as you would imagine. But even then, if you look at the reds, you can still see that question mark look to it. And that is the big question mark. Will this thing put down a wall cloud or a funnel cloud or a tornado? I don't see any big signs of debris, but it certainly is spinning like a top. It may not be a fast-moving top, but that thing is rotating and has now wind damage reported in its path. This is interesting because now we're going to have to go back and look at this radar, and the folks at the Weather Service will allegedly, I'll say that as carefully as I can, tell you or not if it's an actual tornado. There's some politics involved in that, and that deals with whether or not there's a tornado warning out right now. As you know, there's not. So we'll see what they call this. This is called thunderstorm wind damage, tree blocking Ferrum School Road. That's interesting. You know, if there's any more damage reported out of Ferrum, that at least confirms that there's wind damage in here. And even though our correlation coefficient didn't really show it, there's wind damage now coming down in the path of this thing. And again, that follows the fact that there's been rotation in this non-tornado warned storm. This is headed toward you in Spencer, and it's headed towards you in horse pasture. And again, it depends on where you are. It may not provide much fanfare, but in a very small area, you may have a lowering of the clouds. You may have a brief gusty spin-up tornado, or you may have just a wall cloud or some breezy straight line winds as a result of this. That gray, this dark gray, is all the stable rain-cooled air near Stanleytown. So you're safe now in Stanleytown. It's on the edge of this rain-cooled air, and where that warm air gets brought into the storm, you can almost see it again still hooking here to the southwest of Stanleytown. That's where all the activity is, and we just got a new image. So that was the one I was looking at. So this would be the inflow notch of the storm, where the key updraft's getting brought not only into the storm, but it's getting brought up into the storm where it rotates. And then on the backside of the storm, you get descending air in the rear flank downdraft. Because the storm itself bubbles up into the sky, jet streams up here, it forces the jet stream down below it. And so what you end up having is air that's rushing this way, air that's coming into the storm this way, and then kind of rain-cooled air being brought in this way. The whole thing kind of sets up the rolling motion in horizontal and vertical, and it's the accumulation of these over time. Lee Orff has shown on his computer analysis that you can look at on YouTube. Pretty amazing visualizations of reality, how tornadoes actually form, and it's some of the groundbreaking stuff. One of the things that they look at, I should say would be the ZDR product, and for ZDR arcs. Now, I know you're seeing a whole bunch of mess on your screen right now, and you're thinking, okay, what is this? This is still Henry County, and I'm looking at rotation on radar. And the way I can tell you this is rotating is because if I look at the shape of the raindrops, they are more flat than they are tall in the reds. And this is where we have fatter raindrops that are being suspended aloft. I'm up at about 7,700, 7,800 feet. Now around, but not in the updraft, we have, and this is all real, this is all noise and bugs. These are raindrops that are more circular or a little less fat. And if your fat raindrops form a curl or a bit of a pronounced area, that's where your updraft is literally holding the rain up. So if you're out riding around, it's called precip sorting, size sorting. And if you're out riding around a storm in the summertime and all of a sudden you get these big fat blops on the windshield, but it never really rains hard, that's heavy blops of rain that are coming out of the top, those pancake-shaped morsels that come out of the top of a storm. And that's an indication that thing's inhaling air. This, to me, still looks pretty impressive, folks. We're looking at the storm coming out of Stanleytown. And again, we'll put the dual panel up for you here. Trying to see, we do have some wind damage reported that in the path of this near Ferrum earlier. It will be interesting to see if it's still producing damage. No warning out with it yet, just a special weather statement. But I'm going to show you something in a second here. You still see a bit of a hook right there. And again, I'll smooth it out. That's now south of Bassett and Stanley Towns, headed toward you in Spencer and Horse Pasture. And then it'll be heading toward the Stoneville area, or just west of Stoneville, should it maintain there. Trying to think of another location near Price, just west of Price there, northeast of Sandy Ridge in Stokes County, North Carolina. So that would be the area to watch, Rockingham County and the Stokes County in the future here. This is not moving off too fast. It's moving south at about 10 to 15 miles per hour, at times up to 20 miles per hour, depending on how well developed this is. As you know, something gets more well developed. Technically, it's not even a thunderstorm because there's no lightning on it that I can see. But we are indeed seeing the curl and the rotation with it. And we can go over and I can again show you where the damage has been reported and where the past hour of rotation in yellow has been reported. Check it out. Right over Ferrum, and look at what time that damage comes in. Right when the rotation gets to Ferrum, boom. That's when you have your wind damage. Now, again, it's up to the Weather Service whether or not they want to go look at the radar and determine that was straight line wind damage or tornadic wind damage, because as you see, the reason I'm on the air is for rotation, and now we're getting possible damage from that same storm and where it was rotating. It'll be up to Weather Service to figure out if it was a small tornado that they didn't warn on, or if it was straight line winds. And I'm not saying that to be mean, but there are things that happen, I'm sure, in these offices where they have to verify, well, I know that to be true. And if they didn't have a warning out, then that's all I'll say, is that sometimes is a factor in some of the paperwork. All right, and I wouldn't just say that. That's actually happened. We've got a little bit more diffuse rotation now coming into Henry County. Looks like it's just west of Bassett. You can see smoother pixels here indicated by some rain. This may be choking itself a little bit more with the outflow dominating here. We've got a new special weather statement that is out for that area. Special weather statement, Fieldale, Bassett moving south at 15. They've increased the wind speed to 40 miles per hour on this shower, or strong thunderstorms, what they're calling it now, which seems fair. Locations would be Spencer, Bassett. I can tell you it looks like, yes, Bassett's already been hit by this. Bassett, you're probably fine, unless you have an isolated wind damage. It's not a very large area of wind that we're watching, but it's just a small enough area that's spinning just enough. Ridgeway, Fieldale, Horse Pasture, and Price. Those areas are still downstream of this, and it's on its way should it continue. And again, this is a look at the past hour of rotation. And just to show you, it picks it up there, and it actually developed, I think it tracked it longer than an hour once it was up in Roanoke County. Why would it be spinning? Well, it's because up past Boone's Mill, you can see the rotation there as well. It's spinning because there's a front right overhead. And so what you have, front's not showing up here. Let's see if I can pop up. We need to look at our Storm Prediction Center stuff, which is not going to be the most captivating thing to look at, but at the same time, it probably does provide the most value. You can see the hook here, by the way, near Panel Fork, Dillon's Fork, Blackberry. That's where the actual inflow is occurring. So you're kind of in the bear cage here. And again, it's now south of 57, but it's yet to get to 58. Again, the Blue Ridge Airport right near Spencer, moving south onto a heavily traveled highway there, 58. Hopefully not a lot of people on it. Hopefully it's not near the ground, but there are some damaging straight line winds with it. And if you were a storm chaser and you were out here in Patrick County near Patrick Springs and you were looking at this, and assuming there was flat land and no topography, which we know is not the case in Patrick County, but assuming you had a drone or a clear shot at this, and this was broad daylight, more than likely this would be a very photogenic supercell. This would be one of the textbook supercells that has the shelf cloud out in the cold side of it, and the wall cloud rotating, and somewhat of a cloud lowering anyway, and probably some striations in this thing, although it's probably highly topped because the air's a little drier, and we probably don't have anything near the ground. That's why you don't have a warning out with the Weather Service with this, but it's trying its best. And I've been in this area chasing storms before. There was another low precipitation swirl that I caught. Technically a supercell. Yeah, we have them here more often than you think, and we're having one right now, which is why I'm streaming here with you. So we need to analyze some things here, and this will be boring, but the boring stuff is how you get to the exciting stuff. It's how you get to why is Jamey on the air right now when there's no warning out. All right, so we're going to look at the surface, and we're going to go, it's a little hard to see. We'll just pop the regular ones up here, but you can see at the surface that we've got wind out of the east across a good part of the eastern Virginia area. This is a cooler but a damp, moisture-laden wind. So it's coming down out of the north, but it gets to the bay here, and it comes in from the east. And most of these winds today have been coming to the east, kind of like a wedge, but this has been a dry air wedge here. But it has banked moisture up into the mountainous areas of our area, and that happens to be where it's hitting this drier air in orange that's coming around the actual front that tried to make it through the area. So front made it through way down here, but it's got a little bit of an inverted trough right over us where the winds are combining. Now, whenever you have anything that is hitting each other and you've got just enough instability, the wind hitting each other like that can form swirls. It just can, and it's part of the most complicated part of how meteorology works. But in simplest terms, you have winds colliding, you're going to have some eddies and swirls, and different atmospheric elements can enhance that. And we're looking at those right now. These are dew points at 925, a little bit higher off the ground. You can see we go from, get rid of that. We go from easterly winds to southeasterly to south-southeasterly. That's not too far off the ground. At 5,000 feet up, we have no wind, and that's also killing our actual tornado chances with this. That's the good news. There's very light wind. But where we do have wind, it's coming in now out of the north. So we only have this favorable wind shear just in the very bottom kilometer of the atmosphere. So we look at shear here, it's very marginal, hardly even showing up. We look at surface winds, though, we can see the collision of air masses there. And I imagine we've got some jet stream lift. There it is in purple, that little fork that's coming out. You want to be on the right side of that. And we kind of are. That's why the purple areas are showing up. Nothing standing out, though. If you get rid of the blue and go up higher in the atmosphere, you've got a little bit of CAPE, which is the ability for a parcel of air to rise and rise pretty fast. Temperatures are not really that unstable, though. A little bit of storm helicity, which is kind of the sum of all of this. But right there near the boundary is where we've got just a little bit of CAPE, and you can get tornadoes with small CAPE and less than 1,000, and you can have 6,000 joules per kilogram of CAPE and not get anything. It's not an absolute, but it is kind of necessary to have something when you're talking about a tornado. I'm just looking at different things here. I'm looking aloft. There's some waves at 700 millibars, which is about 10,000 feet up. You've got a jet streak coming down at about 18,000 feet. We've got convergence in red, and it's corresponds with our elevated areas of moisture. I'm guessing these are the value. Yeah, the LCLs typically, well, if you look at where the 1,000 is, it is over Henry and Franklin County, typically 1,500 or less. That is the base of the cloud in meters off the ground. And the more moist air you have, the lower the LCLs. Tropical system, you may have an LCL of 500 to 700. This is a case where they're around 1,000. But if you go up into the drier air, it's about 2,000. So that makes it less hard for the spin to make it to the ground because there's less distance to the ground and there's more moisture being released. So some of these values aren't even showing up because we just don't have a lot of wind to begin with to even measure. But what we do have out there, 5 to 10 mile an hour wind, is turning. And sometimes we look back and say, man, we should have been on the air for that. Not seeing anything yet on the weather wire, and it probably won't. Just wanted to kind of cover myself here. 25 to 30 knots a shear. And again, this is working off to the south and east. This front kind of got hung up, and again, that's the boundary that's creating all the trouble. Let's go back to the radar and look at the actual data here. So this is our new special weather statement, and it's just short of a severe thunderstorm warning or a tornado warning in this case. But you can see Spencer there highlighted. You can still see a bit of a hook, a little bit of a red notch there to this. Let's see, at 10:07, Doppler radar tracking a strong thunderstorm near Fieldale or near Bassett, moving south at 15. 40 mile an hour winds or higher. Gusty winds can knock down tree limbs and blow around unsecured objects, trash cans, things like that. Lawn furniture, trampolines. Locations impacted Spencer, Bassett, this is past you now. Ridgeway coming your way. Fieldale in horse pasture and Price. It's going to be closer to the airport in Spencer than anywhere else than it will horse pasture, although horse pasture won't be too far away. And by it, I mean probably just a lowering of the clouds. It's not probably very big. It's just some brief heavy rain. Only reason I'm talking about it is showing up and it is producing rotation, and that rotation has been confirmed where we had spin earlier. We've got damage where we had rotation, in other words. And those are two keys prior to the correlation coefficient that we would have used to confirm tornadoes. Don't have any spotter reports or anything. Time of the night, Sunday night. But you can see here, let me remove my marker, you can follow this. So let's pop that up full. I don't see a lot of green on the map here, but look for the red areas. This is the radar, winds coming toward the radar, greens, reds going away. So let's follow the track of this. Is there a pronounced notch and track that you see? Right there it is, and it actually shows up more if you look a little bit further back in time. This particular radar program doesn't go back as far, but you can see it was over Henry, and we had another little notch there just north of northwest of Henry, and at that point we had a bit of a hook echo too. And I'll put out the 3D imagery on this too. This thing had a weak echo region where the updraft was so strong it was beginning to curl a little bit. So you see the sky that's overhanging and really ominous looking in the daytime. Looking 3D at it now, and you can still kind of see that look. We're looking from the southwest to the northeast. Again, if we were storm chasers, this would be one of our more picturesque storms. Fortunately, the time of night not on our side, and the weather situation wasn't really screaming anything today, unless you were paying really close attention. But you can see this is the inflow here. You're looking 3D at it. So let me try to do this the best I can. Try kind of drawing in 3D here. Your air is coming in like this, and then it's getting brought up into the storm, and then it vents out that way. And even right here, it overshoots a little bit. That's where the radar would be picking up the top of this cloud, and then it spreads out. That's the anvil. Your rain-cooled air, which is, you know, it gets fed out by the jet stream that's pulling it this way. It comes on down and spreads out in all directions. So it's more like straight line winds. but you can actually see that roll there on the very end. Sometimes this can be a shelf cloud. Then you've got your rear flank downdraft that's caused by this big, huge updraft. This spiraling thing that sticks up in the sky hits the jet stream. Jet stream has nowhere to go but up and over, and then part of it gets brought down to the surface. So that starts to wrap back around. So that comes in this way, and sometimes this is dry, cooler air. You don't want it too dry. And that wraps back out and helps form this part of the spin. So it's already spinning, and then when they meet each other, that's where we can tighten that spin just like an ice skater, and you'll start to see the cloud base, which you see here. But real life, if we had a wall cloud, it would come down like this, and it would be rotating. And then beneath that wall cloud, you would have the possible tornado. How big would the tornado be? It wouldn't even show up in one of these pixels. That's how small it is compared to the rest. So when we show you this rotation on radar, this going up into the storm and then out, that is the entire mesocyclone, not the actual. It's like trying to pick out a thunderstorm in a hurricane, basically. Let's see, we'll go back in time here, and you can see it almost looks like something's hitting the ground there. It's just a classic looking supercell in some regards, especially for Franklin County, and a setup that didn't scream anything to us today. But if you go and look at the fact the front got hung up, that's what changed everything. And that's what's led to this low-topped little spinny cell here, a little supercell that was really picturesque here a little bit earlier. I'm glad I put the images out for this. It's really neat to see the overhang. Again, you've got the updraft here, and there's a bit of an overhang, and then where we've cut it off, this is where the air is coming back around it. So this was part of a hook echo. When you take a hook echo and slice it, you can pick out features like that in 3D, and you can see it's at about 22,000 feet, right near the freezing level. There you see it really pronounced. And again, it's just that storm's ability to take air that's here, pull it up, and have those heavier, fatter raindrops suspended in midair, because the air is actually going up, and then it's going down right here, and then again if they meet and start to spin enough, you'll get the tornado. If you compare it to right now, there's not much to look at. That's the good news, but we got to keep in mind I've also moved my domain, or the storm's moved out of the domain. This is the special weather statement. It's still in effect. You can see the reflectivity's died off. That's some good news. Well, we've got just a little rotation, but not much there. Still a bit of a hook, though. We'll smooth that out for you here. You can see that in your Spencer. So it's getting pretty close to Spencer, but I doubt it's more than just a picturesque looking cloud. However, we did have damage earlier in Franklin County. We had some tree down across the road, and we've got more storms up to the north. The reason I told you this was because we've got a dying stationary front. The Weather Prediction Center has erased it since we've been on the air, but there's a boundary over us. That's why it's raining, and the boundary was originally supposed to be east of us, but we've got this, there it is, because we've got low pressure that moved in from the tropics and it's trying to get going something around Myrtle Beach. So sorry, beachgoers too. All right, we'll be back tomorrow with a sunnier forecast. Still cooler than normal, and a pop-up storm in the afternoon.